So how do we calculate measurements involving uncertainties? So the following are the rules apply to calculations involving data with uncertainties. So 1, if the data are to be added or subtracted, add their absolute uncertainties. 2, if data are to be multiplied or divided, add their relative uncertainties. And 3, for a number raised to a power, fractional or not, multiply the relative uncertainty by the power. And for rule number 4, for a number to be multiplied by a constant, multiply the number and uncertainty if it is absolute, and only the number is multiplied by the constant if the uncertainty is relative. So to understand the rules, let us have some examples. So here are the concept builders in your modules. So number 1, the length and width of a rectangle are L is equal to 6.5 plus or minus 0.1 meters, and its width is equal to 3.4 plus or minus 0.2 meters. So we have here our uncertainty of 0.1, our quantity of 6.5, and the quantity of width, which is 3.4, and the uncertainty of width, which is 0.2 meters respectively. So letter A, find the perimeter, and B, find the area of the rectangles. For number 2, the mass of a cubical object is 235.1 plus or minus 0.1 grams. So if one side of the cube measures 5.25 plus or minus 0.05 cm, what is the density of the cube? So let us answer first problem number 1. So the length and width of a rectangle are ito. So these are the given. So first, let us look for the perimeter. So letter A, perimeter. So the perimeter of a rectangle is calculated using this equation. So 2 times quantity length plus width, or 2L, 2 length plus 2 width. So this is just the simplified form. So to do this, we supply here 2 and then 6.5 plus or minus 0.1, and then plus quantity 3.4 plus or minus 0.2. So this is the value of the length with its uncertainty, and this is the value of the width with its uncertainty. So let's go back to the rule and look for so let's go back to the rule. Sabi dito, if data are to be added or subtracted, so in that case, the data are to be added. So if data are to be added to get the uncertainties or to calculate the uncertainties, we add their absolute uncertainties. So remember that the absolute uncertainties is the given uncertainties. Absolute uncertainties of the measurements are the one we identified from our measuring device. So let's go there. Yan, so ito yung solution natin. So our absolute uncertainties are the following. For length, we have 0.1, and for the width, we have 0.2 meters. So sabi doon, if we are going to add measurements, we also add their absolute uncertainties. So here, first we add the quantity 6.5 meters plus 3.4 meters. These are our measured quantities or measured value. And then, so 6.5 plus 3.4 is equal to 9.9 plus or minus the added quantity, combined quantity. So 0.1 plus 0.2 is equal to 0.3 meters. So since here the perimeter is said to be 2 times length plus width, so since we already added the length and the width together with their absolute uncertainties, now let us multiply this to the constant number 2. So now we can now see the application of the third or the fourth rule. So let's see. So here. So sabi dito, for a number to be multiplied by a constant, multiply the number and the uncertainty if it is absolute. So in this problem, this is an absolute uncertainty. So this is the sum of two absolute uncertainties. So sabi dun sa rule number 4, if we are to multiply our measurement, our quantity with a constant, so here the constant is 2, we multiply the quantity with the constant, and if its uncertainty is absolute uncertainty, we also multiply the uncertainty with the constant, so that we'll get 9.9 times 2 will be equal to 19.8, and then 0.3 times 2 is equal to 0.6. So our final measurement for the perimeter, excuse me, so the final measure for the perimeter is 19.8 plus or minus 0.6 meters. So this is the combined uncertainties of these two measurements, of adding these two measurements of the perimeter of this rectangle. So let us now solve for the area of the rectangle. So the area of the rectangle is equal to the length multiplied by the width. So area, so first, multiply muna natin. So kunin muna natin yung area. And then, second is to look for the relative uncertainties. So here, so multiply our given quantity for the length is 6.5 meters, and our given quantity for the width is 3.4 meters. So again, ito yung problem natin dyan. So yan, so the length is 6.5 meters, that is our measured value, and the width is 3.4 meters. So, as you can see, to get the area, we are going to multiply length times width. So, what is the rule? So, what is the rule for multiplying quantities with uncertainties? So, the rule is this one. So, if the data are to be multiplied as well as divided, so if the data are to be multiplied, add their relative uncertainties. So, we need to calculate also for the relative uncertainties. So let's go back to our problem here. Okay, so to get our relative uncertainties, we use this equation delta A, which represents the absolute uncertainty divided by the quantity. So the total relative uncertainty is equal to the relative uncertainty of quantity number 1, or our length, and the relative uncertainty of quantity number 2, which is the width. So the uncertainty, the relative uncertainty, sabi natin, it is calculated using this equation. So we have delta A over delta A for area. So therefore dito we have delta L over L. So itong L is the quantity, yan, 6.5 meters, and then this is the absolute uncertainty of the length. So while the width, so the absolute uncertainty of the width is 0.2 meters, and its and its quantity or measured value is 3.4 meters. So ayan siya, ito for the length, ayan. So this is the absolute divided by the measured value. For the width, this is the absolute uncertainty divided by the measured value, and we need to get the sum of the relative uncertainty. So to get the total uncertainty for this problem, we just add the relative uncertainty. So we also have to substitute, since we have the value for a, since we want to know this one, the value of the uncertainty of for the area, uncertainty of area. So we need also to supply this value 22 meters squared dito. So ito yung final measured value natin, but we need to look for the uncertainty. So 22 meters squared plus or minus what is the value of the uncertainty. So we need to supply this value here. So substitute A with this one. So that will get delta A divided by 22 meters squared is equal to, so the quotient for this one, 0.1 meter divided by 6.5 is equal to this one, and the 0.2 meter divided by 3.4 meter will get this value, and then yung meter will be cancelled out. So, yeah. So delta A now, so cross multiply, so delta A now will be equal to 22 square meter multiplied to the sum of these two. So this value is 0.01538465154 plus 0.05882359294 will yield to this value. So 22 square meter times 0.07420814448. So now we have our value for the uncertainty. So the final uncertainty now, after multiplying the length and width, so the uncertainty of the area is 1.64 square meter or 2 square meter. So remember that uncertainty is expressed in only one significant figure. So therefore, we need to round this off into one significant figure, and that is, the closest is 2. So yeah, since this is 6, then 1 will become 2. So the area, the final measurement now, so the measure of the area of the rectangle is 22 plus or minus 2 squared meter. So to answer problem number 2, so the problem again is, the mass of a cubical object is 235.1 plus or minus 0.1. So this is the absolute uncertainty, and this is the measured value. So that is in terms of gram. So yan ang unit natin. If one side of the cube measures 5.25 plus or minus 0.05 cm, what is its density? So we know that density D is equal to mass divided by the volume of an object or substance. So we know the value of the mass, which is 235.1 grams, and volume, since we know one side, the measure of one side of the cube. To get the volume, we we raise the side to the third power. So yan, para makuha natin yung volume of the cube. So the volume of the cube, so hindi ko lang dyan ipakita, so 5.25 raised to 3 is equal to 144.70 cubic centimeter. So yun. So the density of the cube, using if we get the density of the cube by just dividing the mass and the volume, the measured mass and the volume, we will get 1.62 grams per cubic centimeter. So remember, since this is division, the rule in order to combine the uncertainties, the rule is to add their relative uncertainty. So again, this is how we get the relative uncertainty. So to get the relative uncertainty, we divide we divide the absolute uncertainty by the measured value. Ito yung, for example, this one. So, the mass, so the uncertainty of the mass is 0.1. Ito, 0.1. And then, the measured value natin for the mass is 235.1. So, ayan, 235. Plus, the uncertainty, absolute uncertainty of the volume, which is 0.05. So, this should be cm. So, this is in cm, not meter. And this should be in grams. So, I'm sorry for the typographical error. And then, 0.05, absolute uncertainty of the, tawag dito, absolute uncertainty of the volume, ay, of the measurement divided by the quantity or the measured value. So, 5.25 meters. So, now, ito na. So, to combine, at combination nito, so 0.1 divided by this number plus 0.05 divided by this number, we will get 0.009949160438. So, remember that we also solved for the value of the density. So, we have the density which is equal to 1.62 grams per cubic centimeter. So, we substitute now this variable. We substitute with our calculated value of the density to get this one too. Yan. And then, cross-multiply to isolate D. So, pag na-isolate na natin, then multiply this value to this value so that we'll get this measure of uncertainty. So, we have 0.02 grams per cubic centimeter uncertainty. So, the final measurement of the density now is 1.62 plus or minus 0.02 grams per cubic centimeter. Okay, so next. Okay, so let us now try to understand this graph. So this is the graph showing the uncertainties and as well as errors. So ito, remember, this one is the line of best fit. Ito. So meaning, this line of best fit represents the closest value to the value closest to the true value. So if we have a set of data of measurements, if we do not know the actual value, then this line, the best fit line, represents the value closest to the real value or to the true value of this measurement. So, meron tayo ditong mga vertical bars and horizontal bars. So, these are called the error bars. So, within this, for example, for the vertical bars, this is the okay, so in analyzing graphs, so of course, first we need to know, or we should be familiarized with how to graph. Of course, the dependent variable will always be graphed along the y-axis or the vertical axis, and the independent variable is always graphed along the horizontal line or the x-axis. Now, to go back, so for example, we have the following data points. Yan. So, the following data points represents all the possible values of the measurement. So, here, itong cross na to, itong manipis na linya na to, cross na to. So, we have here the vertical error bar and the horizontal error bar. So, meaning, ito, so yung horizontal error bar represents the range of values for all the possible values for the independent variable, while the horizontal bar represents all the possible values for the dependent variables. So the lowest possible value, of the independent variable is found within the lowest point, or the lowest edge cap of this vertical bar. So let me have my, wait lang, okay, laser pointer. So this one, so in this part is the tip of the lower edge of the vertical bar represents the lowest possible value of the independent variable for this specific data point, and the upper edge cap represents the highest possible value of the independent variable. So meaning the true value of the independent variable lies along this vertical line. So pwedeng andito siya, andyan siya, or so andyan lang siya, yung true value. Because once again, sabi natin that our measurement is never exact. So pwedeng hindi naman talaga siya yung true value. Yun lang yung nabasa natin. So, because we have reading errors. So pwedeng yung true value lies higher or lower, or pwedeng yung measurement mo, that is the true value. But we're never certain if that is really the true value. So for the for the horizontal bar, horizontal error bar, so the left edge cap represents the lowest possible value for the independent variable, and the right edge cap represents the highest possible value for the independent variable. But most of the time, yung mga graphs na ganito showing errors, wala silang pinapakita na independent variable. So wala silang pinapakita na horizontal error bars, because the errors there, or the uncertainties there, are very much can be neglected. So hindi masyadong significant yung effect niya to the measurement. That's why some of the graphs showing errors do not include the horizontal error bar, only the vertical bar. So at this point, so if we create a graph, or if we create a line from the topmost, from the highest possible value here to the lowest possible value of all the measurements, then this line, so the tip of this line, the slope of this line will represent the maximum slope for this data point. So while this one, from the lowest vertical error, or from the lowest possible value of the dependent variable to the highest possible value of the first data point, no, yan. So if you connect these points, then that will give us the minimum slope. So in order for us to know the slope, to calculate for the slope of this trend line, we subtract the maximum and the minimum slope. So maximum slope minus minimum slope divided by 2 will give us the slope of this best fit line. So while the y-intercept, for example here, so the y-intercept of the best fit line is calculated by subtracting the maximum y-intercept and the minimum y-intercept divided by 2. So as you can see, this slope uncertainty is the basis of the range method. So let's go back to that slide showing the range method. So the range method, sabi natin that the range method is this one. So the range method is done by subtracting the lowest possible measurement from the highest possible measured value divided by 2. So, kung pupunta tayo dun sa graph, again, ito, so kung pupunta tayo dito sa graph, so these are all the possible values um, of this data point, and this is the highest possible value of this data point, and the highest possible value for all the data set of data. So this one is the lowest possible value of all the data. So yan. So this one also, so this one is the lowest possible value for this data point, and this one is the highest possible value for this data point. So the the slope of this line and the slope of this line, if we subtract these two and divide it, we will be able to solve for the slope of the trend line, or the uncertainty of the trend line here. So in measurement, remember that in application, there's no such thing as little mistake. So because little mistakes, when you compile it, it will become a big mistake and will lead to, for example, this one, the error in engineering design. So kung maliit lang sa umpisa, pero habang tumatagal, palaki ng palaki yung error. So that's all for this lecture number 1.